Dear students, in the previous two videos, you have learned about interference due to thin films. Now, this interference due to thin films was broadly divided under two categories. One is that a film can be of a constant length, constant thickness, and a film can be of a non-uniform thickness. So these were called the parallel thin films, and these were called the wedge-shaped thin films. You have learnt in great detail about the interference pattern produced by these films and the interference pattern produced by these films. Now, today let us discuss about the fringes that these films produce. Now, remember that the fringes that are produced by films of constant thickness, right? They are called as Haidinger fringes. And the fringes that are produced by the films of non-uniform thickness as above, like wedge-shaped films, they are called as Fizeau fringes. Haidinger was the first person who observed these kinds of fringes, therefore these are named as Haidinger fringes. And a French physicist, namely Louis Fizeau, French physicist he was, right? His name was Louis Fizeau. He was the first person to observe these kinds of fringes, therefore these are called as Fizeau fringes, right? Now, the typical example of Haidinger fringes are those produced in Michelson interferometer, or Fabry-Perot interferometer. You are going to do all of this in the lab work, Fabry-Perot interferometer. And the typical examples of these Fizeau fringes produced in the wedge-shaped films are like those in the Newton's rings. You have done that in the lab. You know that it's a plain glass, you have a plano convex lens, right? Of course, the film that is produced has a non-uniform thickness. It is wedge-shaped. So these are the examples of Fizeau fringes. Similarly, the fringes that are produced due to interference on soap bubbles or by oil surfaces, oil films on the surfaces of water. Due to which we see different types of colors on their surfaces, colors on soap bubbles, colors on the oil films on the surface of water. These are all examples of Fizeau fringes, right? Now, these Haidinger fringes are also known as fringes of equal inclination. Fringes of equal inclination. Now, what do we mean by that? If you recall the reflection and transmission pattern, it was like if the incident ray is like this, the refracted ray is like this, it is again reflected, it is again reflected, transmitted, right? Again here it is reflected, then it is, and then the process continues. Now the angle R, that is angle of refraction, is same everywhere, right? So because of this reason, they are also called as fringes of equal inclination, because R is same everywhere. So they are called fringes of equal inclination. And these are called as fringes of equal thickness. Now, if you recall that when we had calculated the fringe width beta in case of these wedge-shaped films, it came out to be equal to lambda by 2 theta, whether in case of dark fringes or in case of bright fringes. Because the fringe width is same, that means these are called as fringes of equal thickness. Now, one more important thing that you need to learn in common about the fringes of equal thickness and fringes of equal inclination is that when you illuminate these films, the light source used is an extended source. Because on the screen, if you want to observe a broader, a clear interference pattern, you need to have an extended source of light. For instance, let me again draw it, right? So from an extended source of light, you have different rays that are inclined at a given angle. Remember that the angle of incidence is same. It is for that reason that angle of refraction is same, right? So it gets refracted here, reflected here, reflected here. Here it also gets reflected. This is one of the patterns, right? Then in this case it gets refracted, reflected, transmitted. Here it also gets reflected. This is another pattern, right? Similarly, in case of this, it is refracted, reflected, transmitted. Here again it is reflected. So you get a broader pattern, a clear pattern of the interference, and you can obtain those fringes on a screen. Now to obtain that clear pattern, I have told you that we need an extended source and not a point source or a line source. So we need an extended source. Similarly, in case of wedge-shaped films, we need an extended source so that we can get a clear picture of the interference pattern on the screen. So that's all about Haidinger fringes and Fizeau fringes. So you should also point-wise try to learn this distinction between the two. So that's all about it.